has confirmed it's launched an attack on Iran.
At 1400, just hours before the region would shift to daylight saving time, the calm surface of the Persian Gulf was broken by a single radar signature, moving fast and low above the water. At first, it looked like a glitch. One more ghost contact in a sea crowded with tankers, patrol boats, and fishing vessels. But within seconds, alarms began to spread through multiple command centers across the Gulf. What appeared on the screens was not a glitch. It was the beginning of a carefully calculated strike. A massive oil tanker valued at more than $2 billion was slowly crossing one of the world's most important shipping corridors. Every day, millions of barrels of oil pass through these waters, feeding economies across Europe, Asia, and North America. A single successful attack here could ripple across the entire global market. Fuel prices could spike overnight, shipping insurance could collapse, trade routes could freeze, and someone had decided to test exactly how fragile that system really was. The first missile came from the Iranian coastline. It skimmed just meters above the waves, designed to avoid radar detection until the final seconds. But the missile was only the opening move. Minutes later, dozens of small signals appeared across surveillance screens. 32 drones, flying in loose formation, approaching the tanker from multiple directions. Behind them, fast attack boats accelerated through the water like predators closing in on wounded prey. The strategy was simple, but brutal. Cheap weapons, overwhelming numbers. Force the enemy to spend millions of dollars in defensive missiles just to stop machines that cost almost nothing to produce. In modern warfare, sometimes the most dangerous weapon is not the most powerful one, it's the most economical. But something unexpected was already unfolding above the battlefield. High in the sky, an American E-2D Hawkeye surveillance aircraft had been watching the region for hours. Its massive rotating radar dome scanned hundreds of miles of airspace, quietly mapping every aircraft, every drone, every heat signature moving across the Gulf. Within seconds of detecting the swarm, it transmitted precise coordinates to a U.S. Navy destroyer stationed miles away. On board the destroyer, the Aegis combat system came alive. Screens filled with incoming tracks. Intercept solutions calculated instantly. The simplest response would have been obvious. Launch expensive surface-to-air missiles and wipe out the swarm before it reached the tanker. But that response would play directly into the attacker's plan. Instead, commanders waited. Because somewhere beyond the horizon, a pair of MH-60R Seahawk helicopters were already racing toward the threat. Their weapons were not the multi-million-dollar interceptors usually used against drones. What they carried was something far more dangerous to the strategy behind the attack. Guided rockets costing only a fraction of the drones they were designed to destroy. In the humid air above the Persian Gulf, the outcome of this encounter would demonstrate something the world is only beginning to understand. Modern warfare is no longer just about firepower. It is about mathematics, economics, and the invisible race between innovation and strategy. And on this day, one side believed it had already solved the equation. At 1400 local time, under a pale, hazy sky typical for late afternoon in the Persian Gulf, one of the world's busiest maritime corridors moved with its usual rhythm. Massive oil tankers crept slowly through the narrow shipping lanes, escorted by tugboats, and watched carefully by naval patrols scattered across the region. Among them was a supertanker belonging to an international energy consortium, a vessel nearly 400 meters long and carrying over 2 million barrels of crude oil. At current market prices, both the ship and its cargo represented a floating asset worth more than $2 billion. Every hour that tanker remained on schedule meant stability for global supply chains stretching from the refineries of Europe to the industrial centers of Asia. But the Persian Gulf is not just a trade route. It is also one of the most heavily monitored military environments on the planet. Satellites pass overhead every 90 minutes. Radar stations scan the coastlines, and naval ships quietly patrol the water, watching for anything that moves differently from the endless stream of commercial traffic. On this particular afternoon, several of those sensors began to notice something unusual. A coastal radar station detected a fast-moving object leaving the direction of the Iranian shoreline. At first, it appeared similar to dozens of other contacts seen in the area every week. Test flights, patrol aircraft, sometimes even civilian drones used by fishermen or port authorities. But within seconds, analysts noticed a critical detail. The object was flying extremely low, barely 10 meters above the water, a classic flight profile used by anti-ship missiles designed to avoid radar detection until the last possible moment. The missile was believed to be a variant of the Noor anti-ship cruise missile, a weapon derived from earlier Chinese designs and known for its sea-skimming capability. Traveling at nearly 900 kilometers per hour, a missile like this can cross dozens of kilometers of open water in just minutes. For large ships such as oil tankers, which are not built to maneuver quickly, even a near miss could cause catastrophic damage. The hull of a tanker carrying millions of barrels of crude oil is strong, but it is not designed to withstand a high-speed explosive impact. Inside regional monitoring centers, tension rose almost instantly. Shipping control operators began calling vessels in the area, warning them to remain alert and maintain course unless instructed otherwise. Oil tankers cannot simply turn away at high speed. Their enormous mass and deep draft mean that even a small course correction can take several minutes to complete. In narrow shipping corridors like those near the Strait of Hormuz, sudden maneuvers can create even greater danger, risking collisions with other ships. As the radar contact moved closer, additional sensors began tracking the situation. Thermal imaging satellites reportedly detected a brief launch signature from a coastal site that intelligence analysts had previously suspected might house mobile missile launchers. The launch site itself had only been identified a few months earlier during routine surveillance, hidden among warehouses used for civilian shipping equipment. This kind of dual-use infrastructure is common in the region, making it extremely difficult to distinguish military activity from normal commercial operations. The tanker itself continued moving at a steady speed of roughly 15 knots, its massive engines pushing the vessel through warm Gulf waters. On board, the crew had no immediate visual confirmation of the threat. From the bridge, the horizon looked unchanged: blue water, scattered vessels, and the distant silhouette of escort ships. But in modern maritime warfare, danger rarely announces itself visually. It appears first as a line of code on a radar screen hundreds of kilometers away. Within minutes, naval forces operating in the region were already receiving updates. Warships began adjusting their sensor arrays, aircraft monitoring the area changed their patrol patterns, and command networks quietly shifted into a higher state of readiness. What had started as a single radar contact was quickly becoming something far more serious. A possible attack on one of the most valuable and vulnerable targets moving through the Persian Gulf that day. And if the missile reached its target, the consequences would not stop at the surface of the water. The shockwaves could spread through global energy markets, shipping routes, and international politics within hours. While the missile rushing toward the tanker captured the immediate attention of radar operators, it was only the opening move of a much larger strategy. Several minutes after the launch, surveillance systems monitoring the northern part of the Persian Gulf began to detect a growing cluster of small airborne contacts, lifting from different points along the Iranian coastline. At first they appeared scattered and uncoordinated, but within moments the pattern became clear. More than 30 unmanned aerial vehicles were climbing to low altitude and heading toward the same section of sea where the tanker was traveling. The drones were believed to be part of the Shahed family of unmanned systems, widely known for their relatively simple design and long operational range. Unlike large military drones used by major powers, these aircraft are built to be cheap, expendable, and easy to deploy in large numbers. With small piston engines and lightweight composite bodies, a Shahed-type drone can travel hundreds of kilometers while carrying an explosive payload capable of damaging ships, radar systems, or fuel infrastructure. Their greatest advantage is not individual power, but numbers. One drone might be easy to intercept. 30 approaching at once create a far more complicated problem. Iran's military planners had spent years studying how advanced naval defenses operate. Modern warships are protected by layers of technology: radar tracking systems, interceptor missiles, electronic warfare equipment, and close-range defensive guns. But these defenses are expensive. A single modern surface-to-air missile used to intercept a drone can cost hundreds of thousands or even millions of dollars. For a country facing powerful naval forces, this imbalance creates an opportunity. If dozens of inexpensive drones are launched at once, defenders may be forced to use extremely costly weapons just to keep up. This approach is often described as asymmetric warfare. Instead of trying to match the technological strength of an opponent directly, a weaker force attempts to overwhelm that strength with volume and persistence. In theory, even if most of the drones are destroyed, a few could slip through the defensive barrier. And when the target is a slow-moving tanker carrying millions of barrels of oil, even a single successful strike could create an environmental disaster and disrupt global shipping routes. The drones detected that afternoon appeared to be flying in a loose swarm formation. Unlike a tight military formation used by fighter jets, these aircraft maintained irregular spacing, spreading themselves across several kilometers of airspace. This tactic makes it harder for radar-guided defenses to target them efficiently and reduces the chance that a single defensive explosion could destroy multiple drones at once. Some analysts later suggested that several of the drones were equipped with simple navigation algorithms, allowing them to adjust their routes slightly based on the movement of nearby aircraft. At the same time the drones were approaching from the air, radar stations monitoring surface traffic detected unusual movement from several small vessels leaving Iranian territorial waters. These boats were believed to be fast attack craft commonly used by the Islamic Revolutionary Guard Corps Navy. Known for their speed and maneuverability, such boats are capable of reaching speeds above 50 knots and can carry machine guns, rockets, or small anti-ship missiles. In past confrontations, these vessels have often been used to harass commercial ships or probe the reactions of larger naval forces. By combining drones in the air with fast boats on the surface, the attacking force could create confusion for defenders. Warships and aircraft would need to divide their attention between threats coming from multiple directions and at different speeds. Even a few minutes of hesitation could be enough to allow some of the drones to reach their intended target. What made the situation even more dangerous was the timing. Commercial satellite data later suggested that the attack had been planned to coincide with a period of unusually dense tanker traffic in the region. At least 9 large oil carriers were traveling through nearby shipping lanes at the same time. If defensive forces misidentified the target or debris from intercepted drones struck another vessel, the incident could escalate rapidly into a much larger crisis. As the swarm moved steadily over the water, their small engines producing a faint buzzing sound barely audible above the waves, the distance between the drones and the tanker continued to shrink. On radar screens across several command centers, dozens of blinking symbols advanced slowly but relentlessly toward the same point on the map. What had begun as a single missile launch was now unfolding into a coordinated swarm attack designed to test not just the strength of naval defenses, but their endurance. Several hundred kilometers away from the tanker, the first clear picture of the developing situation was forming inside the command cabin of a U.S. Navy E-2D Hawkeye airborne early warning aircraft. From the outside, the aircraft looked almost unusual, with its massive rotating radar dome mounted above the fuselage. But that dome contained one of the most powerful airborne radar systems ever deployed at sea. Flying at an altitude of nearly 9 kilometers, the Hawkeye had a view of the Gulf that stretched for hundreds of kilometers in every direction. Long before the crew of the tanker or even nearby ships could see anything, the Hawkeye's sensors were already tracking dozens of moving signals above the water. Inside the dimly lit cabin, radar operators watched as the swarm gradually appeared on their screens. Each drone registered as a small but consistent radar return, moving at a speed that confirmed what analysts already suspected. These were not random civilian aircraft or weather balloons drifting in the wind. They were controlled objects, moving with purpose toward a specific target. The radar system's advanced tracking software began grouping the signals automatically, identifying patterns in their movement, and predicting possible intercept points. Within seconds, encrypted data links transmitted the entire air picture to nearby U.S. naval assets. One of those vessels was the Arleigh Burke-class destroyer USS McFall, operating as part of a regional security patrol. Warships of this class are equipped with the Aegis Combat System, a highly integrated network that combines radar tracking, missile control, and automated threat analysis. When the data from the Hawkeye arrived, the destroyer's computers immediately began calculating possible defensive responses. On the bridge and in the Combat Information Center, the situation looked complicated but not unfamiliar. Naval officers train extensively for scenarios involving drone swarms and missile threats. Yet what made this particular encounter unusual was the scale of the swarm combined with the cost equation involved in stopping it. A modern interceptor missile fired from a destroyer can cost between $1 and $4 million, depending on the variant. These weapons are designed to stop high-speed aircraft, incoming missiles, or ballistic threats. Using them against relatively small drones would guarantee interception, but it would also mean spending enormous resources on targets that cost only a fraction as much to produce. This imbalance has become one of the defining problems of modern defense. Over the past decade, relatively inexpensive drones have forced even the most advanced militaries to rethink how they protect ships, bases, and infrastructure. A defender who responds with expensive missiles every time a cheap drone appears risks exhausting their arsenal very quickly. In prolonged conflicts, the side that manages resources more efficiently often gains the advantage. Inside the destroyer's command center, officers began evaluating alternative responses. The Aegis system continued to track every drone in real time, updating their positions several times per second. The destroyer's SPY-1 radar provided extremely precise tracking data, but launching a full missile defense response against dozens of small targets could rapidly drain the ship's vertical launch system cells. Even a powerful warship carries a limited number of missiles, and commanders must always consider what might happen if a larger attack followed. At the same time, other American assets in the region were already moving into position. Two MH-60R Seahawk helicopters that had been conducting maritime patrol operations were redirected toward the swarm's projected flight path. The Seahawk is one of the U.S. Navy's most versatile helicopters, capable of performing anti-submarine warfare, search and rescue missions, and surface surveillance. But in recent years, the aircraft has also become an important platform for counter-drone operations. Mounted beneath the wings of the helicopters were pods containing Hydra 70 rockets, a weapon originally designed decades ago for ground attack missions. For many years, these rockets were unguided, meaning they relied on simple ballistic trajectories after launch. However, a modern upgrade known as APKWS, the Advanced Precision Kill Weapon System, transformed these inexpensive rockets into precision-guided munitions by adding a laser guidance kit between the rocket motor and the warhead. The result is a weapon that costs only a small fraction of traditional missiles, but can strike targets with remarkable accuracy when guided by a laser designator. In recent conflicts, APKWS rockets have proven highly effective against drones and small, fast-moving targets. For naval forces dealing with swarm attacks, they offer a crucial advantage: affordability combined with precision. As the helicopters approached the projected intercept zone, pilots began coordinating with operators aboard the Hawkeye and the destroyer. Data from multiple sensors, airborne radar, ship-based radar, and infrared detection systems was fused into a single tactical picture. This networked approach allowed the helicopter crews to know exactly where the drones were, even before they could see them visually. The pilots descended to a lower altitude, positioning themselves between the swarm and the tanker. Through targeting pods mounted beneath the helicopter nose, they began scanning the horizon for the small heat signatures produced by the drone engines. Even tiny piston engines generate distinct thermal patterns, especially against the cooler background of open water. Moments later, the first drones appeared as small specks moving steadily across the sky. They were still several kilometers away, but closing quickly. The helicopter crews switched their targeting systems into laser designation mode. A narrow beam of coded laser energy was projected toward the lead drone, invisible to the human eye, but clearly detected by the guidance sensors inside the APKWS rockets. The first rocket launched with a sharp flash and a trail of smoke. Unlike a large missile, the Hydra rocket accelerated almost instantly, streaking toward the target at high speed. As the rocket approached, its guidance fins adjusted slightly to keep it aligned with the reflected laser energy. Seconds later, the drone disappeared in a brief burst of flame and fragments. Almost immediately, another rocket followed, then another. Because the rockets were relatively small and carried in pods containing multiple rounds, the helicopters could fire repeatedly in rapid succession. Each launch cost only a fraction of what a ship-launched interceptor missile would require. In effect, the defenders had found a way to reverse the economic equation that the attackers had hoped to exploit. While the helicopters engaged the drones at medium range, the destroyer remained ready to activate additional defensive layers if necessary. The ship's close-in weapon systems and electronic warfare equipment stood by in case any drones slipped through the aerial interception zone. But as the rockets continued to streak across the sky, it became increasingly clear that the swarm was beginning to break apart. Fragments of destroyed drones fell into the Gulf waters, leaving brief splashes on the surface before disappearing beneath the waves. Radar operators watched as the number of active targets steadily decreased. What had once appeared as a dense cluster of approaching signals gradually turned into scattered remnants of the swarm, many already eliminated before they could come anywhere near the tanker. The attack that had been designed to overwhelm defenses with numbers was now encountering an unexpected obstacle, a response that was not only precise, but economically sustainable. In modern warfare, where technology evolves as quickly as strategy, sometimes the most decisive advantage comes not from the most expensive weapon on the battlefield, but from the one that solves the problem in the most efficient way. By the time the last drone disappeared from the tactical display screens, the situation in the Persian Gulf had changed from a potential disaster to a demonstration of how modern military systems are evolving to confront new threats. The tanker that had been at the center of the unfolding crisis continued moving through the shipping corridor, almost exactly on schedule. From the deck, the crew could see distant flashes on the horizon and faint smoke trails dissolving into the humid Gulf air. But the vessel itself remained untouched. What could have turned into a major disruption of global oil supply had instead become a tightly controlled defensive operation. For military analysts observing the incident later, the most important result was not simply the destruction of the incoming drones, but the method used to stop them. As mentioned earlier, the attack relied heavily on the economic logic of asymmetric warfare, forcing a technologically advanced opponent to spend large amounts of money defending against cheap weapons. That strategy has been used in various forms for years, particularly in regions where drones and improvised aerial systems have become increasingly accessible. However, the response demonstrated that modern defense systems are adapting quickly. Instead of relying exclusively on expensive interceptors designed for high-end threats such as aircraft or cruise missiles, forces are increasingly integrating layered defenses that include lower-cost precision weapons, electronic warfare tools, and networked sensor systems. By combining aircraft, ships, and surveillance platforms into a shared operational network, commanders can allocate the most efficient weapon for each specific threat. Equally important was the role of information dominance. Throughout the encounter, multiple surveillance platforms, from airborne radar to infrared detection systems, fed data into a shared tactical network. This allowed operators to track every object involved in the attack with remarkable precision. Some defense experts later noted that such integrated data sharing can reduce response times by several seconds, which in fast-moving engagements can be the difference between interception and impact. In addition to the immediate defensive success, the engagement also produced valuable intelligence.